MiniConf. I think we're going to get started. In the back, we've got music production with deep learning with Brian Lee, and in the front, we have Docker containers for beginners with Carlos Castro. Woohoo!
Okay, hello everybody. Welcome. Thank you for coming. I'm going to give a talk about Docker containers for complete beginners. First, who am I? Why am I here? My name is Carlos, as you know. I have more than 3 years of experience in software engineering. I'm a software engineer. I have worked with consultancy for the financial sector in Mexico. So I've worked with Java mostly, ActionScript, JavaScript, application servers such as Glassfish, JBoss, WebLogic, databases such as Oracle and Microsoft SQL. And so I have a bit of experience on how to operate and how to develop some of the systems. And why am I here? Why am I in Tokyo right now, across the globe, 10,000 kilometers away from Mexico? Well, just I always liked Japan. I always liked the culture, respect for the people, the respect for the nature, and I always wanted to see what was that all about. So I'm here, and let's see here what we have in the outline. What's on the agenda? We're going to see what the problem with the shipping software is. What is Docker? Docker containers, of course. Docker images. What is a Docker file? The architecture of Docker, how to integrate it to your developer operation right now, and a little demo. Also, what's not on the agenda, I'm not going to be talking about microservices, nor orchestration tools such as Kubernetes, or cloud platforms such as Google and Amazon. Okay, first, let's review a little bit of the dev pipeline right now, where you have your plan, then you go through your code, you're building, testing, releasing, deploying, and all that stuff. I had this pipeline as I was working. The company that I was consulting for, it had around 20 clients. So we had around 2 pipelines like this for every single client. So I had to work with around 40 pipelines like this. So I had a lot of problems in terms of shipping my software to those clients. And when you move to production, you also get trouble with your app because it probably is not working the same as in the QA server. So this was the setup that I was working on at a very high level. I was working on the app server side with Glassfish, and there was also an engine, and the engine was the only work of an engine was to talk to the central bank, feed the database with some data, so the client can see that data through the applications that were living on the application server. And everything was just fine. They're both using Java as the environment to run, and they're both doing fine until we had to move from version 6.20 that they were both running to version 8.151 for the application server. And why is this a problem? Not because they couldn't live together, but because we sometimes forgot that we need that specific version. And it was not always in my hands to install this application Java into the server. So sometimes people would forget that that is a dependency that we need. So we were running into a lot of problems like, I need to test my application, but Java is not installed, so it cannot run, or that is not the right version of Java. And we are human. We forget about this thing. We think that we overthink or overview the dependencies are not as important, but they are as important as the code themselves. So there's a way to solve this. You can probably use virtual machines for that. There's a couple of big players out there. There's VirtualBox, there's VMware, and of course you have your Microsoft implementation of virtual machines. But there's a problem with this. The size of the virtual machines are in the size of the gigabyte. So if I had 20 pipelines that I need to ship, 20 virtual machines, around 40 gigabytes per virtual machine, that would be a lot of work, and that would be very difficult. And so it happens that we, and the real world had that problem many years ago, where we have to deliver goods to parts of the world, and we need to ship them, but the way we ship them was tightly coupled to the things itself, to the goods itself. So if I were to send a piano from, I don't know, from United States to Europe, it was tightly coupled to the shape of the piano and how the piano will be handled when I was sending it and when it was received. I had to care about if the people that was receiving it had the right equipment to carry that piano. How is that piano going to be carried? When I'm shipping it, do I have the right equipment to ship the piano? And so the people who had this problem, this man tried to solve it by standardizing it into a unit of shipping, And he came out with the containers, the shipping containers. So the shipping containers became a standard because now everybody in the planet knows how to handle a shipping container, which is a little bit of generic how to carry it. They know where the doors are, they know the shape of the container, they know where the ID is, they know everything, but they don't really care about what's in the container. They just care about how to handle the container themselves. So right now, if I want to ship stuff like a piano, I don't really have to care about whether they can carry the shape of my piano. The only thing I have to care is to put my piano in my container and then send that shipping container, and they will handle it for me. In the same way, Docker is trying to handle software in that same way, where you don't really have to care about what's in the container. The only thing you have to care is how you send the container and how the container is going to be received and if it's going to run. So, what is Docker exactly? Well, Docker is an open platform for developing, shipping, and running applications. You don't really have to care a lot about how the people it's receiving your application. It's just gonna run. It helps with shipping and deployment because you don't really have to care about whether the people who is receiving have the infrastructure to deploy your application. So you only send them the right amount of data that they can have, that you can need to have handled for your application to run. And it runs everywhere. Right now, Docker has a pretty broad platform. It can run on Microsoft, can run on Linux, and can run on macOS. So you can pretty much run it everywhere. So what is a container exactly? It's standardized unit of deployment. It is disposable, and it is lightweight. It is, again, the right amount of data that I need for my application to run without me having to worry about too much about what my dependencies are or how it's being handled by the other person. So, why containers and not virtual machines? The first point is that machine size it's in the order of the gigabytes. And also you have this sort of spectrum where on the one side you have the virtual machines with the most generic way that you can send your application that will ensure your application to run everywhere. But you're also sending this a lot more data than you need to. You're also sending a whole machine. And on the other side of that spectrum is the least and the minimum side of the data that you can ship, which is, in case of a Java application, a file called a jar or jar application. So, but in order for me to give you that jar, I would expect the other person to have an environment or an infrastructure that could run my jar, and that could be deployable. So the containers are kind of in the middle. They are the right amount of data. They ensure that your application is going to run when it's received, and you don't have to care whether the other person has the infrastructure to run a jar or another type of application. So let's look a little bit about the history. Does anybody knows what this logo stands for? Does anybody knows that logo? Yes?
Heroku.
Yes. What is Heroku exactly?
So it's basically somewhere you can deploy things pretty easily. You just put a proc file in your thing and
Yeah. So
run in your package and off it goes.
So Heroku is a platform as a service. .cloud, which is this logo stands for, it was also a platform as a service. So the selling point of both Heroku and .cloud is that you can send them your application, and they will do whatever it takes. They will handle dependencies, and they will deploy it, and you will have a running application deployed somewhere that you can use. So the people at .cloud had this problem, and I'm sure Heroku ran into it once or twice at some point. That okay, so you don't know what kind of application you're gonna receive. You kind of have like the broad idea, but you don't really know what specific thing that application is gonna need. So you need to have a pretty complex infrastructure to try to run that application. Otherwise, it wouldn't be pointless to sell that value point. So this guy, which is Solomon Hykes, founder of .cloud, also co-founded Docker, and they came out with this idea of trying to standardize how we ship software. They did not create containerization technology at all. They just try to use it to to solve the problems. Actually, they just try to use it to be able to deploy your application anywhere, and it suddenly became the most popular thing that they ever did, and became a company on its own. So right now, where's Docker right now? Docker, by the numbers, they have 80 billion container downloads. That is a pretty big number. Let that sink in a little bit. Container downloads refers to this. Docker has this hub, private repository place where you can put your images and people will download them. It's public, so people can upload and download images. Also, companies can do that. So they have 80 billion container downloads. It is an open source project, so they have 32,000 GitHub stars right now. And they have 650 commercial customers right now running in production, so that's pretty big. Who is using right now? They have now conferences around the globe. DockerCon is pretty popular. Also, before I forget, this is the sixth birthday of Docker. So this month, Docker's turning 6 years old, so it's a pretty nice platform. And who is using Docker right now? Well, it's being used by pretty big players like PayPal, Microsoft, Visa, Google Cloud Platform, Amazon WS, web services. So it's a pretty good service. So now let's talk about images. Who knows what this is? Has anyone seen Rick and Morty here? Yes? Well, this is a V6 box. Can anyone tell me what a V6 box do? Well, the V6 box create Mr. V6 to be exactly. The Mr. V6 are created by this box, and then they'll be assigned a task, and once they fulfill the task, they will disappear. So let's look at that life cycle looks like. You have your box, you press your button, then you have your Mr. V6. You assign a task to the Mr. V6. The Mr. V6 completes the task, and then the Mr. V6 disappears. In the same way, a Docker image works the same. A Docker image is the base of all containers, which means it's kind of like a V6 box. A V6 can create multiple Mr. V6. So in the same way, a Docker image can create and give birth multiple Docker containers. And this is one of the reasons why Docker has become very popular with microservices, because it allows you to scale very quickly and very easily your application. It's also created by layers. So you have this construction of images by layers, and every time you do a change to your image, it's just another layer being stored on that image. So it's kind of like an instruction set for what your container should do, for what your application should do when it's created and when it's out there. And you can create the image based on commands. You can do everything to the image based on commands, but that's pretty ineffective in the way that those are a lot of commands. So they created a Docker file. And a Docker file is that set of instructions. It's a literal file. It goes in the same folder as your project. So here, it is the set of instructions that when the image is created, this will follow. So I have an example of a Docker file. Have a little bit of commands, and let's see how that works. So the first one is the from image. So it tells the image where is it being, what is going to be used as a base. Is it going to be using a Node platform? Is it going to use a Linux platform as the base of that container? Then that's a layer. The next layer, it's going to set the working directory to this path. You can set it to whatever path you want. So that's another layer. And then it copies package.json. This is a Node application, so you have a package.json. This Docker file goes into the same file system as your project, so you can have access to the files of your project. So you're gonna copy the package.json to current directory, and that's another layer. And everything you do, exposing ports, copying files, running commands, everything that is another layer. So every change that you make to your application, and when you rebuild your image, you're not rebuilding the whole image, you're just adding the layer that is missing. So let's see how it works, how the Docker architecture works. This is a typical high-level architecture of how Docker will be in your computer. That might be changes if you're from environment to environment. But the first thing you'll see is the Docker CLI. That's your entry point to the Docker world. The Docker CLI will communicate to the REST API. And then the REST API will talk to the Docker daemon. And the Docker daemon is the central piece of this architecture, because it is what, it's basically the Docker core. It will talk to the containers, talk to the images, talk to the registry, this public space where you can pull or push your Docker images. So the Docker daemon pretty much does all the heavy lifting that you need. Okay, so now how do I integrate Docker to my developing process? We talked about how Docker will allow you to run your application everywhere. You just need to pack that in an image and send that, and they will give your container. They will run your container. But it's not only for you to ship stuff. You can also use stuff. So it is also for you to allow you to have a somewhat almost the same environment that you're running into production right now in your local environment. So it's also for, if I want an SQL, MySQL, or a Postgres database running inside my machine, but I don't really want to use the installer, I can just pull the image from that repository and start a container with my database. And one of 2 or 3 steps, a couple of commands, I have already a running database in my machine. Also, if I'm running a specific application or version of my application in my production server, and I have a bug and I need to replicate that, I can just get the image from that application, run that container, and I'm running the same application in my local environment that is running in production right now, and I can start debugging. So in the case of my example before, that I have this kind of setup, where you need to run two versions of the same environment, which is Java. That could be easily solved using containers, because I will only pack a container that contains my engine, and another container that has my application server and the other applications that need to run in the version 8 of the Java environment. So dependencies would be not such a big problem in that situation. So I'm going to show you a couple of commands right now. This is probably what you're going to see if you install Docker, and this is probably the first one you're gonna be dealing with. The first one is Docker images, which allows you to list all the images that you have in your local machine. And they have the repository, which is the name, the tag, which is another name for the version of that repository. You can give it when you create your own Docker image, you can give it a version, whatever you want. The convention is to have your user / and then your application, and then your version. You will also have an image ID. This is a unique identifier. This is a Chaz string, and all containers and images have this ID, and it's as I said, a unique identifier for your image or your container in this whole environment. When it was created and the size of that image. The next one is run container. This is probably the most important one, and this is probably the most complicated one. But it typically goes like Docker run, and then you can give it a bunch of options. You need to tell them which image is gonna run, and then you're gonna have another options or arguments that your container can have as input. And the next one is port binding. Every container by default is isolated, so when you have a running container, it runs in this intranet with the Docker environment, but it doesn't know that you have a local host or anything like that. So if in case that I need something from my container in the terms that I need to go to a specific port and get data from it, that binding needs to be done, because my Docker container doesn't know where it's being run, and my local host will try to go to that port, but it's not bound to the Docker, so Docker doesn't know. Docker is isolated. So this port binding command allows you to bind two ports, your host port to the container port. And then we have a list of containers, which is Docker PS. This comes somewhat the same as Docker images. You have your container ID, which is unique. You have your what image is being run from, what command it starts with, when it was created, the status, and if it has or not port bindings. And there's also a name. This name is probably not really useful. In terms of, as I said, containers are disposable, so this name is being generated automatically every time you start a container. So you can give it a name, but probably not that useful. The next one is stop container. This one's pretty simple. Just Docker stop. Give it a bunch of options. And what container are you gonna stop? You can use both the name and the unique identifier. The good thing is you don't really need to use the whole Chaz string, which has a bunch of characters. You just need to give it a unique string that can identify your Docker container, which in this case is probably can be 2, 3 characters, 4 characters. The next one will be Docker remove. Docker is Docker rm. You have a couple of options, and then again the container. This will remove the containers that are working or not from your current development system. Then there is the interactive mode. This is mostly if you want to run commands inside your container. This one is running Ubuntu, for example, and I'm telling that I want to use bin bash, and this will attach my command line to the command line of the container. And I can start typing commands to the container itself. So, in order for me, when I was learning Docker containers a couple of years ago, there was this world of, okay, this is a pretty good piece of technology, yes, but when you start seeing the Docker CLI and every command that it has to offer, it's such a wide world. You don't know where to start. It's, okay, I run the hello world, now what? So it's kind of like weird, it's kind of overwhelming having to look through this whole documentation, learn a couple of commands. If you're not a CLI guy, it's fine. So it's a very overwhelming. So I built an application for me to have a bit of management over the containers and the images in a more easy way, more non-CLI way. So I built this first version in 3 days, and it was already managing start and stop containers and a couple of basic stuff. The idea of this, I wanted to manage both the image and containers in a non-CLI way. So I don't have to deal with the CLI at all. I don't want that. I just want to go into my browser and click a button, and suddenly all the magic is gonna be done for me. All the commands that I don't want to learn, or I just don't want to deal with. So I'm going to show it to you. This is version 2. And at first glance, you can see images, all the images that I have installed. And the first thing, as always good, let's go run hello world in Docker. I just click that button. I just need the version. Of course, I can give it options because we see the run command has options. Just give it a version and start container. I don't have to worry about running commands at all. Then I can go to the container section and it will show me the running containers, or the created containers, to be more specific. Doesn't have to be running. This, for example, is not running, has a status of exited. from the Node.js backend. I'm using Socket to fetch the logs because they can keep going. And the backend is talking to the Docker daemon through that REST API that the Docker daemon exposes. So I'm sending commands, HTTP commands to the Docker daemon and receiving the information that the daemon is returning. Everything running on my local machine. So let's summarize a few things that we talked about. The first thing, why Docker is useful, it allows me to ship and deploy more easily. It is a way for me to send the right amount of data that my application needs to in order to run. I'm just sending what my application needs. And I don't really have to care about whether the person that is receiving, whether that server that it's running production has the tools to deploy my Java application or my Node application. So it makes it scale more easily. We've seen it with the Mr. Music. So I can create a bunch of containers running the same application, and I can scale as easy as that. And finally, makes it possible to set up local development environments. Where they're running on my server, on production server. Again, it's I can have a problem running in production, and I just can start debugging by pulling out the image that it's running out there. So it allows me to have pretty much an exact copy in my local machine that is running in production for me without having to worry about this unstabilizing or doing stuff in production. So nobody wants that. And thank you very much for coming. I'll be around. I can have a question or two, and I'll be around if you want to keep talking about Docker.
All right, so we have about 5 minutes for questions. For Carlos, does anyone have any questions?
Yeah.
I have a friend who wanted to learn programming, and he is using Windows and having a big trouble installing Node.js, which is kind of understandable. And so, how I want to create like a container and then send it to him, like create a container on my Mac OS and send it to him on his Windows machines. How may I do that?
You can, if you want to create a node image. And you can go to the Docker Hub, and there's already a node image built in, so he can just pull it right now. There's a concept called Scratch in the Docker files, which is creating an image basically from scratch. But unless you're working for developing Node or for developing an entire Ubuntu system or something like that, my recommendation is go to the Docker Hub, pull down the official Node image, and start using containers.
I got a question. How do you decide what's the best container software? I mean, there's Docker, but there's other ones too.
That's a pretty good question. It's just a matter of, for me specifically, it's a matter of implementation. Yes, you have Docker. Yes, you have other. Docker did not invent containerization technology, but you can see it. You can see it by the numbers. It has a bunch of companies running it right now in production. We saw it in Visa, PayPal, and stuff like that. So it is a it's continually being supported. So it's not like suddenly you're choosing Docker for your whole architecture of your company, and tomorrow it's gonna disappear, and you're gonna have old blog posts for 3 years ago of like how to fix this bug. So for me specifically, will be the great adaptation and great acceptance that Docker as a company and as a platform has right now.
So you're saying like containers are meant to be sort of ephemeral. You can make them and then you can remove them like that. What's the life scale like? Why would, in a real business case, why would somebody want to create a container and then kill it right away? Is it just is it mostly for scalability of an application, or?
I haven't seen that. like in real life. But what I can say is that if you're running such a big or large scale using containers, you're gonna have into scalability issues. So you can scale up, create more containers, but if you're serving an application, your network's gonna have spikes. So when you have like a big spike, when the users are more promptly to log in or something like that, you are gonna need more power to hold that information, to hold that request. And after that, you are going to don't need it. So what is the point of keep maintaining all that energy and all that data alive if it's not going to be used? So you start removing containers. Yeah, that's the way I see it.
We have time for one more question. All right. Thank you, everyone. We have another presentation happening in probably about 10 minutes. It's going to be what is Google search actually doing? That's over here. And then on the other side will be Filmmaker.
Okay, welcome everyone. This is session 2 from 2 o'clock, supposed to be. And in this session, we're going to see what Google Search is actually doing. So let me just introduce myself. I have a really different background. I was a professional ballet dancer in the country of Georgia. And I just decided to support athletes and artists more using technology, and that's why I came back to Japan. And in the previous years, I experienced not only dancers, but also teacher, jury, writer, editor, translator, a lot of things. And now, why am I talking about Google? Because I was just curious about what led Google to successful product-based business. Google has very good quality for their product, and their core product is basically Google Search. And their continuous high quality of this Google Search actually made them possible to compete against Microsoft. In the 90s, Microsoft was like one of the biggest companies, even now, yes. But Google actually compete very well against Microsoft because they had very good quality for their product. And also, these days we have many SNS, but we have very specific way of using SNS, while we use Google for almost anything, everything. Yeah. So that's why I decided to have a look at what Google is doing. So today's table of contents. First of all, I'm gonna just have a look at brief history of information retrieval, so we can know why and how Google ends up having their product as it is now. And also, I'm gonna explain a bit about crawling. Part 2 is about PageRank, their basic algorithm, and SEO. And in the part 3, we are going to see recent updates of their Google search algorithm, and also about single page applications. So the very first part, brief history of information retrieval. We are going to see why Google has what it has now. So we start from the very ancient times. We already had library before Jesus Christ. So the first library existed actually in 2600 BC. And then you can actually find some mention in the Greek document in history. People use, for example, in the Greek drama, they were announcing the table of contents before the Greek drama started, so people know what's going to happen in the drama. That was very important because people need to know almost what is going to happen before it is going to happen, because if it's not something you want to know about, you will not be there, right? So this existed, and then at that time library didn't have the paper and the book made of paper, right? So that was made of papyrus, parchment, and then invention of paper actually led them to the more easy production of books. And then actually that happened in the 15th century. So Gutenberg invented the movable printing press that actually made them possible to have more books anywhere, not only in the, for example, the capital of the country, but also some city could have like some library that could store many information, right? So the more books they have, the more important it became to have some way of retrieve information from the lot of books, basically. So the needs of categorization actually was more and more important. That's why they invented library catalog, for example. And also because the book now has the same content on the same page, so indexing actually worked after the Gutenberg's printing press. So now we can search some information by searching the page number. For example, if you go to page 54, you can have this information. So that was useful, but that was not enough. So in 1940s, it was a time of computer. Computer was basically a calculator at the beginning, but then they realized they can use this for retrieving some information from a lot of resources. So, for example, in 1950s, no, it was 1940s, they used computers they got an idea of using computers to search for relevant pieces of information. And also in 1950s, they got idea of automating information retrieval. So that was one factor that actually made Google possible to have their product. But there is another missing link, which is www, which is World Wide Web. Should be familiar with all of you. So link analysis is basically the way of retrieving information based on the relationship between with another information. So the relationship was important to retrieve some information. And also World Wide Web was created in 1989. That makes internet possible to happen, basically. So that was another missing link for Google. But still, it was not enough because we are getting more information, but this very good way of retrieving information was still missing. So people feel like we have so much information which is useful, we can maybe find some information, but we don't know how. And then 1998, Sergey Brin and Larry Page published a paper while they were at university. And that was about the algorithm called PageRank. That was the basic algorithm they used first for Google. And also, interestingly, in the same year, John Kleinberg, this guy introduced a new algorithm at HIT. This is now using ask.com. And they are different algorithms, but interestingly, they were published in the same year. So this was the turning point for information retrieval. So now, I'm going to explain why, it happened, why Google kind of reached their algorithm. So now we're going to see how crawling works. So what is crawling? Is everyone familiar with crawling here? Not really. I'm going to explain that. So crawling is to visit a web page and retrieve information about that page. It's very simple. So what is crawling? Visually, basically there is a spider, which is also a crawler. Spider is gonna find all the links, and it goes to some link, retrieve information, come back. Retrieve information from another link, come back. Google has its own spider, just called Googlebot. And Googlebot goes to one page, and in that page there are many links as well. So it also goes to that link to retrieve information from that page. So the important thing here is a crawl rate limit, which is what Googlebot is trying to set. So what is crawl budget? There are two factors for that. One is crawl rate limit, another is crawl demand. Crawl rate limit is basically for Google to stop itself from retrieving information too fast. Because if it goes to the many links so fast, it's gonna speed down the server on that web page, right? So it's trying to have the limit of getting information from that page. But if the Google bot cannot get information in that time limit, it's gonna say, okay, this web page, this server is really slow. So this is one thing. Another thing is crawl demand. So Google is gonna see if your web page is popular, if it is new, if it is original. We're going to see more into the details in the SEO part. But that is what Googlebot is trying to find. So how does crawler work more specifically? So basically, before you actually make a search, Googlebot is already trying to search information. So here's a spider. It goes to the web server to get some information. And it sends HTML back to crawler, which is a spider. And it's going to store information in the Google index. And that's why when you search some words in Google, you can get result very quickly because it is already stored in the index. This is a basic idea of crawler works. So, web information retrieval. Google used to crawl once a month, which is not so often, right? But these days, they do almost every day. Even after 1 minute you publish your web page, you could get some result from the Google search. So it is crazy nowadays. One thing I have to note is there is a way to also block Googlebot from crawling. You can use it for good reason, but also that might actually lower the ranking of your web page. So this is one thing I'm going to explain later, which is about robots.txt. But this is one thing you have to be careful about. So this is a very quick review about the basic of crawling. Any questions so far? Is that? Yes.
Question. Like when you say that every day the Google bot crawls the pages to keep for the crawling, how does it determine the starting point for from which link or like which page it should start crawling?
If it goes to one web page, of course it has so many links there, so it knows where to go, right? But it's a very good question because the truth is Google doesn't publish its core algorithm to the as an open source, so no one exactly knows where and how it starts crawling. But one thing which is one thing that is for sure is it is crawling every day, and you can see that in the result because there is some tool to see how result is changing. it's kind of a SEO tool. So you can confirm that it is changing very quickly. But as for your question, honestly, I don't really know because it is kind of secret for Google. But there's of course a way to decide which one to start with. So I will look into it. Thank you for good question. Anything else? Okay, I'll go into PageRank now, which is the basic algorithm of Google search. So PageRank was famous for kind of the fact that it is kind of notorious because we're going to see. PageRank was before visible to anyone. It was inside the Google toolbar, so you can see your web page was ranked. It was the scale it was like on 1 to 10 scale, so you can see if your web page was like rank 9 or 5 or 6, but now you can't really see because there were many problems about this PageRank. So before actually going to the PageRank, I'm going to explain about web graph. So graph is a data structure. It's a structure of objects that describes how they are related to each other, which is very related to link analysis. So web graph is a graph that describes how web pages are directly related to other pages in the World Wide Web. It is like this. Each node is a website, and it is related with the direction, which is a link. So how can you rank? So for example, the website A has 3 inlinks, and each inlink has a value. So let's say it has 3 inlinks, and each of the link has a value 20, 50, and 30. So the value of this website A is 100. And then you divide by 2. So it has another outlink, 2 outlinks. So for each, it's going to divide its value 50-50. Meaning that website C has a value of 50. What about D? D actually has 1 inlink, but it has so much value, 240. So although it has 1 inlink, it has a value of 240, meaning that its outlinks have value of 120. So the website B has a rank 170, and website E has a rank value of 170. This is kind of basic idea of how PageRank works. So now you can decide the value of each web page based on the relationships between each web pages. But of course it is harder to know inlink because you know where your website you have outlinks to, but it is harder to know always to know like okay, I have linked to this web page, but I don't know who actually has linked to my website, right? So what is the feature? What is special about PageRank? It is independent from query. As I explained before, crawling actually works before you actually search some words, meaning that it can determine the rank of a page by crawling static dataset, and it is not based on, basically it is independent from query, meaning that it is very quick when you search. And also, why is PageRank famous now? Because Google succeeded. And another thing is, Ask.com, for example, is using the algorithm that has query dependence. So it is actually a bit different algorithm, but mathematically you can switch this independence. And that was most of it. Yes. Did you notice what was the problem about PageRank with that basic idea? Any? Yes.
Can't see the inflow. I mean, actual traffic.
If what do you mean by
I
traffic?
mean, like, so the actual sort query, because you said like, it's independent from query.
Right.
So you said very static, but people sometimes, like in the fashion, like today, that everyone's searching cat apps.
Yeah.
How do people can figure it out with the page number?
Yeah. Okay. So that was one problem. That was actually solved later by Google after this problem with SEO. But we're going to see later. Another problem is that you can manipulate the rank of web page by having more inlinks or outlinks. So that was what SEO was doing before. So let's see the problem of PageRank. So a lot of people realize that we can manipulate this algorithm by having more inlinks and outlinks. So they actually started so many businesses that we're going to sell the outlinks for you. It has so much value, so you can rank up. And that was a problem. I'm going to see the case of Search King. And also, you might get unexpected results by that, right? That was a problem. So, what is SEO? SEO stands for Search Engine Optimization. Sounds cool. A lot of papers also have tried to reveal Google's secret, because that was that could be also explained mathematically. It was also like kind of good. Mathematically, you can explain this algorithm very simply. So it was also one of the topic for the academic papers. And this is the reason why PageRank is no longer the only factor in Google's algorithm these days. So one of the things they did was term spamming. Term spamming is basically to create websites that are indexed with high position search engines. And one of the things they did was like this web page. It is not very clear maybe, but the category is countries, but it has so many words about casino, bonus, these things. So when you maybe search casinos, you can hit this website, and then it has more people coming to that website. We used to have these web pages so often actually. So that was a huge issue in the 90s. One of the techniques was hiding techniques. So for example, you can't really find any words on the website, but it is kind of empty. And if you click and drag the web page, you can see a lot of white keywords. So that was stuff. The crawler is gonna find these words as like some information about this web page. So that was how they actually tried to rank up the web page. Also, there was a hidden link. I'm gonna show the example here. So this is HTML tag. Inside, it has a link, but it is not visible in the actual web page. But it has a link. So this is how they actually also tried to rank up the web page. And it was not visible to the users, so they have used this kind of technique as well. Also, comment out to the keywords. I'm not exactly sure if all the crawler is gonna see comment out to the keywords, but that was also apparently one of the techniques. Also, you use the meta tag in HTML because there's a description part. So that was another technique, which is not useful for these days, but they used this kind of technique before. Also, this is more technical technique, cloaking. Basically, what it is doing is to have 2 pages for different purpose. So for crawlers, it's gonna show the normal web page. I'm fine. This is a very good web page, but for users, it shows a different web page. And this is very hard for crawlers to find if it is doing this technique. So Google used to ask the web surfers a lot, if you find some problems, please tell us. So this kind of technique was used so often by SEO companies, and then we ended up having the weird result as well. So people kind of try to use inlinks and hylinks so often, and then, I mean, I don't want to offend anyone here, but this was happening before. When you search miserable failure, you ended up finding one name of the president, and this why it is called Google bomb is that it takes time to have so many inlinks and outlinks, and it's like a timer. So people don't realize at first, and then eventually they got this web page in the top, and that was happening before as well. So that was kind of joke in the website web pages. And then the Search King, what is that? It is a company that was selling the web page that have a very high rank. And then it was their business, and then one day they realized the web pages they had was lowered to 6 from 10 without any announcement from Google. So they filed a lawsuit against Google saying that you have to pay us because we've lost so much money, and also you have to reveal all the secrets and what was changing at that time. Please tell us. And then that was a kind of issue to Google, of course, and Google said that the algorithm is the core product for us. It is about our business, so we can't show you what is happening in the algorithm. Google won against Search King, but it became clear that SEO actually has many problems as well. It is the way to optimize your web rank, but that was a huge issue. So Google thought, well, Google tried to change everything. So these days, not only just numbers matter, but also inlink should come from the page of high importance. This is why these days algorithm Google search is more complicated than before. And it is now fueled by semantic and contextual understanding. We're going to see what kind of algorithm and basically what kind of updates actually made them possible to do this. So specific target keywords are not as important these days. People think we have to have very good keywords to have get some information from the web page, but actually it's gonna try to understand what you are trying to get, what you are trying to search. So what is good? What is important these days? There are some tips for SEO which you can start from today. So first of all, there is a very useful tool created by Google. It is the Google Search Console. It has many features that you can use, and one of them is also to create robots.txt. What is robots.txt? It is very simple. It's just a text file. I can try to find it here. So, for example, Amazon.com. There you go. It's the Amazon page. And then, simply, if you want to see what is robots.txt, /robots.txt, and then you can see this text file very easily. you can see disallow. That means that it's gonna disallow the web page to be visible for crawlers. So crawlers cannot crawl these pages, and you can simply and easily create these robots of text in your website by using Google Search Console. So back to the slide. There you go. And make sure your pages are crawlable. You can use robots.txt to disallow your web pages, but that might also lower the rank because you might actually disallow the very important pages in your website. So be sure that you disallow the not important web pages. And also limit redirects. We used to see a lot of web pages that have a link. It goes to some very different web pages. So redirects are recognized by Google to be a little bit annoying. So make sure that you're not using redirects so often. Also eliminate broken links. It is also important. Avoid using URL parameters. What is URL parameters? In the URL, when you search something like some keywords, for example, you're going to see question mark and then some keywords equals something, this kind of thing. So basically, based on what you try on the web page, it's gonna direct to the different results, different web pages. So avoid using too many URL parameters because it is not sometimes unexpected for the users. Crawlers want to avoid this kind of URL parameters. Also use internal linking, external linking, improve your server speed so crawler can get all the information from your website. Cache your web pages, so it's going to speed up your server. Optimize page load speed as well. All those things you can start from today. So that was the second part of my session. Any questions so far?
Sorry, what do you mean by internal links and external links?
So in your website, you might have a lot of web pages linked together, right? Which is internal linking. So external meaning that it's basically the in-link and out-links, which is harder to manipulate, but internal links basically about inside your website, how it is related to each other. Any other questions?
What
Yes.
else the Google search like crawler does for the self-linking? Like pages are self-linking. So what does it count like for in-rank or out-rank? How they are kind of classified?
Okay, self-link to its own web page. When, for example, when do you want to use it? Is it just as a technique?
Sometimes like the back button or like we have those self-linking because it would be linking back to the
Like
website.
back to the top of the web page.
Yeah, kind of. Yeah, internal linking might be where you can.
Honestly, I'm not super sure, but to go back to the top of the web page, that is probably. That's a good question. I never thought about it. Just definitely some link, some sort of link, but I'm not really sure if the crawler is going to count that as one of the web page link, because it's just going back to the same page. It's not going to reload the web page, right? It just moves inside that web page, so it might not be counted as in link. That's also one of the things I'm going to look for. Yeah.
Another one very simple question that does the robot.txt also prevent us from like bots and attacks?
Sorry.
Robot.txt, if I allow like disallow some part, it also like prevent not from the crawler but from the bot. like there are many bots like which are trying to attack or kind of put a DDoS attack. So does robo.txt also prevent that?
Well, one thing I'm pretty sure about is that it's gonna work for Google bot, but since there are many kinds of spiders, crawlers, it might actually work differently. But one thing that is pretty sure is that this is about Google search, right? So robots.txt definitely affects the rank of your web page, but for different uses, I'm not sure if it's gonna work same. Okay, so the last part, recent updates Google search algorithm. So we now know that page rank is not the only factor. So it has so much history. This Google search is not only about searching words. Nowadays, you can use voice search, search by image. There are many different features. And today I want to focus on only this. It's really maybe weird. So this is the history of Google, let's say, and it has some very important updates. One is panda, another is penguin, and the last one is hummingbird. What is that? People actually call that Google Panda. It was released 6 years ago. It's interesting that Google is using, maybe it's SEO is calling that as Google Panda. But a lot of algorithm updates were named after the animals. So what is Google Panda? It was really strong. Google Panda kicks low quality content. So if the web page has very low quality content, it's going to lower the rank of your web page. It's going to see content farming. So, for example, some kind of website hires so many freelance writers to write about so many things, so it can have many inlinks and many keywords. Content farming was also kicked out. Think content is also bad. Duplicate content inside your web page, that was also not useful anymore. Lack of authority, trustworthiness, high add to content ratio inside the web page, and content mismatching search query, that is also not good. Google Panda is going to see all these things, and that actually affected up to 12% of the English web page in the world. Huge effect. What about Google Penguin? It's also about SEO. So it's gonna see link schemes, keyword stuffing. It only sees these two, but that also affected really well. So normal and natural backlinks work, and normal cheap tricks like keyword stuffing work. That was Google Penguin. What about Google Hummingbird? It's a bit different. Google Panda and Google Penguin are the basically updates about the algorithm. This was more like a new feature to that algorithm. So it was totally new. What is Hummingbird doing? It's gonna try to understand the intent of what you want to see in the Google search results pages. So for example, I tried to search movie where Master and Padawan fight on the planet of volcano. I didn't mention anything about Star Wars. I just tried to explain just one of the parts in this movie, and it found Star Wars. So it's gonna try to understand what you are trying to search in Google search. So the specific keyword is not important as before. It also has Pigeon. Google has Pigeon. What is it doing? It is about local research results. For example, if you search like pizza in Tokyo, or Tokyo pizza, let's say, it's gonna probably show the results related to those words. So it didn't really matter if it existed in Tokyo or maybe just the name, it is just a name in somewhere else. But now, Google Pigeon is more precise, so it's gonna try to find the pizza place near the location of where you are, and it's gonna just pick up 3 results with a map. So it had huge emphasis on traditional organic search and basically where you are. So that was also really big change for the local business. It was more for the business to have the better results, and so people can find that store or shops. Yeah, local SEO basics as well. Another thing I want to explain is Google Mobile. That was released 3 years ago, and basically when you search one, for example, called Chrysalis in your mobile and also in your laptop, you might get different results. So it's gonna see what kind of device you're using. That was a huge change as well for the Google algorithm. And what about more updates? Google's actually released almost 500 to 600 updates per year. And not all of them are publicly announced. But there are some tools. One of the tools is Moscast. And Moscast is gonna show you the weathercast of Google search algorithm updates. For example, this is I think from the last week. Yes, last week. And then you can clearly see something happened on that day. So you can pick up some updates according to these tools. It also has some blogs to show you what happened. We guess this happened, something like this. So you can still follow these update changes. One last thing I want to mention is SPAs. SPAs, what is that? It's not onsen, it's not spa. It is about JavaScript. People use JavaScript so often these days. So SPAs stands for single page applications. All these applications are created as SPAs. What is single page applications? It means it doesn't reload web page every time when you click some button. For example, when you search in something in the Google map, it's not going to reload the whole thing, right? It's going to show you the result without reloading. That is a single page application, and it is very popular these days. And what are the problems? In terms of SEO, Googlebot or the normal crawlers normally try to see HTML files, which is static. But JavaScript makes it possible to see the web pages more dynamically. And Googlebot actually try to get all the information about JavaScript as well these days. So it's gonna wait for 30 seconds or something. But the page can be, that web page can be indexed, does not mean that it will run well as well. So we have to be still careful about how to use SPAs in terms of SEO. So there are some techniques, or let's say the technology that we are using to for this SSR, server-side rendering and pre-rendering. First of all, there's also client-side rendering. What is a client-side rendering? Basically, when you send a request to a web page, it's gonna, okay, I get some requests, so I'm gonna get some information, there you go. So it's gonna reload every time. What about server-side rendering? when the server gets request, it's gonna try to get results inside the server and then return the information. So it's not always going to reload, but the server always deal with all the requests. On the other hand, pre-rendering is a little bit different. Basically, pre-rendering gets all information already before you do something on web page. So it has everything there. So when the client sends a request, it's gonna just do the task. Okay, when we get this task, I'm gonna just give you this. So it's very quick, but it's not that flexible as server-side rendering. So downside of server-side rendering, all of these. So for example, server needs to do everything by itself. So it has more additional load, response is slower. Also, to create this server-side rendering for developers is complicated and time-consuming. Also, for example, when you want to use window object, you cannot use in the Node.js, for example. So your code needs to be universal. And to fix that, you can use some framework like Next.js, but it's still complicated for developers. That's the downside. What about the pre-rendering? Since it already does some tasks that was already, so basically it does the thing, but it's not flexible. So it doesn't change according to your data on the website. For example, this one actually changed according to the current rank or the popularity of the web pages, but that's not possible with pre-rendering. Also, if your web page shows you some information on web pages according to the user's data, that is also not difficult. That is also difficult for pre-rendering. So there are some downsides for pre-rendering and server-side renderings, but you can maybe try for SEO. So this is this balance you have to think of. So in conclusion, Google search algorithm is not only about page rank. We have to see a lot of different factors as well. So for historical reasons, especially with SEO, it combines tons of different algorithms. And if you want to create web page that ranks high, make it friendly both for human and also for crawlers. And if you want to create a web page that ranks super high, you probably want to see the updates of Google search algorithm because it changes every year. What works well today doesn't work well maybe tomorrow. If you're the mathematic person, also there is a very good book. It has many, basically it is about linear mathematic metrics, these things. So this is a book if you want to see what is actually happening in the page rank. So there are also resources, Google and SEO, about Google and SEO. It has 5 links in each QR code. So if you want to know more about Google and SEO, please scan it. Thank you for listening today.
All right.
Hi everyone,
Hi.
I'm Keisuke Mori, and thank you for coming my tech talk. Today I would like to talk to you about build your own Google Home using Raspberry Pi. And here is a table of contents. First, let me introduce myself, and I want to talk about overview. And second part is settings. Settings of Raspberry Pi and settings of Google Assistant. And third part is how to create Google Assistant applications I want to show you 3 examples, and I want to explain it, and I want to show the demo. Finally, I want to do the conclusion. So let me introduce myself. I'm Keisuke Mori, and I'm from Tokushima, Japan. And I worked as 2 IT companies before, and as systems analyst and application engineers. And now I join the called Chrysalis and enjoy the new technologies. Also, let me introduce my technical skills. Before I joined the called Chrysalis, I used these technologies such as jQuery and Java and Spring and so on. Yeah, of course, this kind of technology is used a lot of systems, but it's not latest technology. So I felt I was behind the trend, and so I wanted to learn new technologies. And now I joined the called Chrysalis, and I can run these modern technologies such as Node.js, Express, GraphQL, React, and Vue, and Heroku, and so on. So now I'm sure I'll be a full stack engineer. Okay, overview. Today's my topic is how to build the smart speakers in Raspberry Pi. And this figure shows the application's concept. If I say something phrase, then smart speaker listens my voice and recognize it and connect to the some applications and get information and return me by voice. This is application's concept. Okay, next thing is settings of Raspberry Pi. So what is Raspberry Pi? Raspberry Pi is developed by Raspberry Pi Foundation, and it's small and cheap computers. And yeah, you can buy various models which has different specs, such as CPU and memories, and price. Raspberry Pi is the highest model is about 5,000 yen, and the cheapest model is about 1,000 yen. So it's very cheap. And also Raspberry Pi can attach some sensors. Yeah, it means can measure the temperature and can measure the humidity, and you can use it in your applications. So Raspberry Pi used for educations because it's cheap and it can do so many things. So students can learn the basic of computer science and IoT's technologies. And also Raspberry Pi uses for industries. In this case, Raspberry Pi uses a supercomputer, and also some of them uses Raspberry Pi and create Kubernetes clusters. And also, Raspberry Pi is used as hobbies. Some developers created game emulators by using Raspberry Pis. So Raspberry Pi is used so many industries. Here are the machine specs and accessories I used. I choose Raspberry Pi 3 model B+. This is the highest model. And CPU is 1.4 GHz and quad-core processors, and memory is 1 GB. So maybe it's less than your smartphone. And micro SD card. I choose a 16 GB micro SD card for safety, but it said at least 4 GB SD card is needed. And also I use charger, HDMI cable, and protection case. And protection case is very important. because Raspberry Pi is very delicate. So if you drop your Raspberry Pi, then the data will disappear. So I highly recommended to use this kind of protection case. And monitor, I use, you can use any kind of HDMI monitors, and but if you want to bring your Raspberry Pi to outside, I highly recommend it to use this kind of monitors. It's a monitor, but it also protection case, so it's very useful. And also, I use a keyboard and mouse, and also I recommend it to use this kind of keyboard. This keyboard merged keyboard and trackpad. So you just use this one to manipulate the Raspberry Pi. And I also use microphone and speakers. And here is the hardware architectures. As I mentioned before, I use mouse and keyboard, and charger, and HDMI monitors, and microphones, and speakers. Yeah, here. This is a hardware architecture. And next step is how to install the OS to Raspberry Pi. So Nubes is installer. Nubes is OS install managers provided by Raspberry Pi Foundations. So yeah, Nubes means new out-of-box software. And I highly recommend to use Nubes because for beginners, because usually if you want to install the OS to the Raspberry Pi, you need to write OS images to your SD card. So it means you need to use other applications. But in case of Nubes, you don't need to use writer applications. You just copy the file to your SD card. Yes, so yeah, you just copy the files to SD card. So you prepare the OS images, and you insert your SD card to Raspberry Pi and power on. Then you can see this kind of screens, and yeah, there are many OSs in Raspberry Pi, such as Linux and Windows 10 IoT and so on. And yeah, you can choose the OS images from this Windows, but I used Raspbian OS because Raspbian OS is recommended by official, and also Google Assistant recommended these OSs. So I choose Raspbian. Okay, next is settings Google Assistant. So yeah, if you want to create smart speaker applications, you need to enable the Google Assistant APIs. So first, open the browser and go to the Actions on Google Console page. And if you do not have the Google account, you need to create your account. And next, you have to create a Google Cloud Platform project and register your device. In this case, you need to register your Raspberry Pi. And this screen shows my actions on Google page. And I already created a project. Yeah, so yeah, you need to create a project here. And next is go to the Google APIs page, and you have to enable the Google Assistant APIs. I already enabled the Google Assistant APIs, but if we go to this page, you can see the buttons, and so you can enable the Google Assistant APIs. And finally, you have to create a credential in this page, and download the credential and put it to your Raspberry Pis. And this credential is used to call the Google Assistant APIs. And so I used Google Assistant SDKs. Google provides two SDKs to develop the applications. One is a Google Assistant service, and one is a Google Assistant libraries. So this figure shows a difference of both SDKs. And Google Assistant service. Google Assistant service supported many architectures. It means Linux and Windows and so on. And also, Google Assistant service supported many languages. It means Python or Node.js or so on, many languages. But this SDK is very simple. It means if we want to use this kind of hands-free activation, it means if you say, OK Google, then speaker return response. If you want to use it, you need to implement it by yourself. So yeah, you need to write your code. On the other hand, Google Assistant libraries. Google Assistant library only supported Linux, and it means Raspberry Pi Model 3 and other Linux machines has same specs or more better specs than Raspberry Pi 3. And also, it's only supported Python. But Google Assistant library is very rich. It means you can use hands-free activation or timers and alarms. You can use these functions natively. So I choose Google Assistant library because I use Raspberry Pi 3 and I want to use Google Assistant functions. So next step is install SDK and install the sample code. So go to your access to your Raspberry Pis and install the Python 3 and install the SDK, Google Assistant SDK package, and install the sample code. And finally, you have to generate a credential, and this credential is based on your downloaded credential. And you have to generate credential, and this credential is used to call the API. So after you finish the settings, and before you run the sample code, you need to register devices. And yeah, you just run the Google Assistant demo command, then your Raspberry Pi is registered in Google Cloud. So you can run the sample code. Okay, and yeah, I prepared the movies, but I want to show you the demo. Okay, maybe hard to see, but this is a console window, and this window connects Raspberry Pi by SSH. So this is the inside of Raspberry Pi, and this is a sample code, and I'm going to run this command. Yeah, now my speaker listen to my voice. So, hey Google, how are you?
I'm doing great. Thanks for asking. What can I help you with?
Hey Google, please give me a joke.
Sure, here's one of my favorites. I once fell in love with an encyclopedia. I was completely infatuated.
Thank you, Google. Yeah, you can run sample codes very easy, like this. So I explained two topics, how to install Raspberry Pi and how to install the Google Assistant SDKs. And from here, I would like to talk about how to create the Google Assistant applications. And yeah, IFT, I used IFT to connect the web services. And IFT means if this then that. And IFT is a platform to can connect the web services to the other web services very easily. So you just set the web services as this statement, and other web services as that statement. Then both applications can connect each other. So if there are so many applications can use in IFT, for example, Twitter and some SMS and email and Evernote. Yeah, these applications can use in IFT and can connect each other. Okay, first example is send a Slack message by your voice. Here is the concept of applications. When you wake up in morning and you feel you do not want to go to work, then you say, hey Google, I do not want to go to work. Then next, your speaker listens your voice and recognize it. And your smart speaker call the Google Cloud. But if you set IFT hook this command, and IFT pass the command to Slack, and Slack posted message to channel. Yay! And you can fall asleep again. This is a concept. So, how to set up the IFT? This is a Google Assistant settings, and you just input the phrase and you just input the assistant response. So it means in input field, what do you want to say? And response field, what do you want the assistant to say in response? And I want to share you important point here. This input field should be simple and easy to say, because if your message matches the text of text by recognized your smart speakers, if matches, then IFT hooks your command and post to the Slack. So yeah, this input field should be simple. It means you don't have to write any symbols, it means such as comma and period and question marks and so on. You don't need to write here. And next is Slack settings. Yeah, you can choose you can choose a channel or direct message here, and I choose channels here. And also, you can input a message to post Slack here. And finally, you save it. Okay, I want to show you the demo. Hey Google, I do not want to go to work.
Posted the message to Slack.
Nice. So go back to my, yeah, this is my test Slack channel, and you can see this one. Yes, I posted 331, and I said I'd like to take a day off today. I have a cold. So yeah, as you may know, I succeeded to post a message to Slack, but one problem is here. Yeah, message is sent by IFT, so I couldn't override these icons and names. Yeah, it's a sub point. Okay, next example is checks weather and commute route. Here is the concept. When you wake up in the morning and you say, "Hey Google, morning," then your speaker listen your voice and access to the weather and calendar and maps informations and get informations and return to me. And yeah, it will be raining today, so I can prepare the umbrella, and so I can go to work finding. This is the second example's concept. And in this case, you just change the settings of your Google Home applications. So first, install the Google Home applications and open the assistant settings, and you can create routines, and routine consists of some actions. It means this is examples. This is a routines examples, and routine consists some actions. In my case, I use tell me about the weather, tell me about my commute to work, tell me about today's calendars. These actions are already provided by Google, so you just use it. And here is routines examples. I created this custom routine. So I want to show you the demo. Hey Google, morning.
Right now in Minato, it's 14 degrees and clear. Today, it'll be clear with a forecast high of 15 and a low of 6. It should take 6 minutes by car.
Yeah. So, yeah. inside the smart speakers, a smart speaker access these information, weather and calendars and maps. Yeah, if you do it in your smartphone, you can see these screens. Yeah, this is a second example. And last one is taking memo by your voice. And here is the concept of applications. When you are sleeping, you got a great idea. So you say, I got a great idea. Hey Google, please record blah blah blah. Then your smart speaker listen your voice and recognize your voice. And yeah, if hook your command and access to the Evernote, and Evernote create a note. Yeah, you can fall asleep again. This is the application's concept. So here is a Google Assistant settings of IFT. It's very similar to the first ones. So you just input the phrase, you just input the assistant response. But one different thing is the input field. Yeah, input field has $mark, and $mark means variables. So in this case, you said please record blah blah blah, and blah 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 is a variable here. So you need to input, you need to type the $signs here. And this is a setting of Evernote. And you just input your note title, and yeah, body is you do not need to change the bodies. This text field means $marks variables, so you don't have to change this field. And just save it, and yeah, it's okay. So I want to show you the demo. Hey Google, please record good morning, good afternoon, good evening.
Save the memo in Evernote.
Nice. So this is my Evernote page, and you can see this note. This note is created a few seconds ago. So yeah, taking memories correctly. Oh, good morning. I see. Yeah, as you may know, I succeed to record my voice. But yeah, I want to share the two things. In this case, yeah, I tried testing to speak long sentence, but it's hard to recognize the smart speakers. If I couldn't say it at once, then smart speaker stop listening, and yeah, so it's hard to recognize. And yeah, and next, okay, conclusions. Okay, I introduced the Raspberry Pi, and Raspberry Pi installing is very easy. And I also said how to install the Google Assistant SDKs. And also I showed some examples, and yeah, I created some applications using IFT. And yeah, now I feel smart speakers potential because you said one phrase, you said something phrase, then your speakers listening and recognize and get the information and return the message for me. Yeah, and yeah, so I think this kind of technology is still developing, but in near future, yeah, we can do more great things by using smart speakers. And finally, I want to share the tips. And yeah, if you can speak 2 or more languages, I highly recommend it to use one language, because Google Home can set 2 languages, and in my case, I set Japanese and English. And sometimes smart speaker didn't recognize my wake-up word, because in case of English, I say, "Hey Google," but in case of Japanese, I say, "Okay Google" or "Ne Google." So it's different. So I guess
I'd help, but I don't know the answer.
Thank you. Thank you. Thank you, Google. Yeah. So yeah, I guess these speakers listen one language at first. So yeah. So if you use 2 languages, and if you want to say difficult things, and then if you couldn't say a phrase at once, then smart speaker try understanding the other languages. In my case, I think I say English, but my speaker understand my voice as Japanese. So yeah, it doesn't work. So I highly recommend to set one language, because if I set one language, smart speaker try understanding one language. So accuracy of recognition is good. Yeah, this is my tips. All right. Hey Google, please say thanks to everyone.
In Japanese, you would say, みんなありがとう.
All right, thank you very much. So if anyone has questions for Keisuke, he'll be around. We do have another round.
All right, hello everyone. Thank you for coming here today. I'm going to be talking to you about blockchain for the use case of international trade and getting started with building your first blockchain decentralized applications. So a bit of background about me. I am a software engineer taking my first steps in this space. I come from Switzerland. I spent most of my life there, and my first career was in the commodities business, like Jan was just mentioning. So I worked for a company that trades things like coffee, wheat, corn, metals around the world. But eventually I decided I was more interested in how technology could transform this space than I was in the space itself. And blockchain was prominent among those technologies that came to mind. So I decided to take a leap and come to Code Chrysalis and discover what is a new country for me in the process. So here I am in Japan. A bit about what I've done at Code Chrysalis. Over the last 8 weeks, I've gotten full stack exposure from the server side to the client side, working with technologies like Node, Express, Vue, React, deploying on Heroku, experiencing databases. And this project was an opportunity for me to kind of segue into blockchain, that I was something that I was interested in before coming here. So what are we going to talk about today in more detail? You can think of it as two parts. First, I'm going to talk about the high-level use case of international trade for blockchain, and then I'm going to talk about how I got started building my app and then demonstrate it for you. Unfortunately, a few interesting things are not on the agenda. The details of what a blockchain is would take 20 or 30 minutes to explain. If you have any questions, we can talk about it at the end. We're not talking about cryptocurrencies, and we're not talking about different blockchain platforms. So whether Ethereum is better than Hyperledger or Corda is better than Ethereum. Although these are definitely interesting topics. International trade, what do we mean? Let's start with some definitions. So international trade is the exchange of goods across borders. If you buy something off Amazon that is from another country, that counts as international trade. But for our purposes today, we're going to focus on larger volumes, and to contextualize it for the Japanese audience specifically, I'm talking about what these companies do. So we're talking about someone who's importing coal or natural gas or sugar or corn or coffee or copper by the shipload or the container load. So generally not consumer products, but like bought in large quantities. Having spent 3 years in that space, I can crystallize it as being very much about managing risk. When you're buying goods or selling goods to a different country, you have to manage currency risk. You're exposed to the fluctuations of different currencies. You have to manage counterparty risk, meaning what if the seller or the buyer don't perform their side of the contract? You're exposed to political risk. What if suddenly there are tariffs or war breaks out? You're also exposed to documentation risk, and that's something people think about less. Every country tends to have customs, and customs can easily say, oh, well, the document on that shipment, I don't like it, so I'm not going to let these goods inside the country. But the risks that I'd like to focus on today are risks that revolve around trust. So let's take the example of a chain of coffee shops in Japan that wants to buy coffee from a cooperative of farmers in Colombia. So let's get into the shoes of this cooperative first, the seller. How are they thinking about risk in terms of how they trust their client in Japan? The first question: what if my buyer doesn't pay? If he doesn't pay, it's quite expensive for this cooperative to come to Japan and take them to court. They might want to be They might want to be paid sooner than when the actual shipment arrives. If you're shipping it halfway around the world, it may take 60 days, it may be delayed, it can take a few months, and actually it may even sink, but you don't want the responsibility for that. You want to be able to get your payment sometime near the time that you actually put the goods on a ship. Now our coffee chain in Japan, what are they thinking? They're thinking, I'm going to buy coffee from this person in Colombia. How do I know that they are going to ship the goods once I pay them? Colombia is a faraway place. I don't know anything about the country. How do I trust that this person I'm talking to will actually put something on a ship and sell it to me? But more importantly, you actually need a way to ensure that your seller is actually shipping what you asked for. So let's say our coffee chain here is kind of picky. They want specifically fair trade coffee, right? So how do you know that he really will ship fair trade coffee? And actually, how do you know that he's not gonna just ship you bags full of sand? So these are things that that could happen. The point is, you can't assume people have good intentions, and as a company, you're always you always have to manage those risks in a professional way, or assume them away and take the risk. So how are these risks managed today? The first thing is intermediaries, and the second thing is paperwork, a lot of paperwork, and I'm gonna kind of take you through an example of how this works. So let's focus on one particular document that is key to shipping things across borders. To explain the example. So you have this thing called the bill of lading. The bill of lading is essentially a document issued by a carrier, so for example a shipping line, to say that they have received the goods and they are shipping them. So for example, you issue it to say, I've received 5 containers of Colombian coffee and I'm shipping them to Japan. The other function of a bill of lading, and an important one, is that it acts as a document of title. So whoever is holding this physical document actually has title to the goods. And it can't be digital yet, because if you start sending PDFs of this document, then you can't actually trace who owns the goods. So we haven't reached a state of affairs yet where we can validate the title of something being shipped other than by someone presenting the physical document in one way or another. So yeah, this is an example of paperwork, and once. To then think about how how people think about risk on the bill of lading in particular, they're going to ask a few questions. As the buyer, you're going to say, okay, once I pay my seller, how do I know I'm going to receive this bill of lading? How do I know that they're going to send it? And as the seller, you also are asking yourself, how do I know that when I send this bill of lading in the mail to the buyer or his representative, how do I know that I will be paid? And today, this is mostly managed by banks as intermediaries. So let's take the example of HSBC. It's a large global bank. What they may do is go to the seller and say, look, I have a branch in Japan. If you send me the documents, I will dispatch them to Japan only once I've received payment. And on the other side, the Japanese branch will say, I will pay only. They will tell the buyer that I will pay the seller only once I've received and checked that the documents are in order. So this is basically what you call trade finance. It lubricates global trade. And you get a flow that kind of looks like this, where the buyer and the seller choose the bank as a trusted intermediary, and it's essentially saying that you trust the bank as a source of truth rather than the counterparty to the contract. So I've described kind of a vanilla transaction. They can look quite different. So the reality is that the ecosystem is quite complex. There are a lot of nodes, first of all, because there's much more documentation than what I've just described. So for example, if you want fair trade coffee, is it enough that the seller says, oh, this was grown fair trade by farmers who are well paid? No, you need some sort of organization, a third party, to certify that this is fair trade coffee. You also need someone to say, to issue a phytosanitary certificate, because you're not going to be paying for goods that once they arrived are declared unfit for human consumption. So these are just examples of documents where you need a third party as your source of truth and reliability. And the thing I would add is there are a variety of transaction formats depending on the levels of trust between counterparties, but this friction in trust is a common theme, so you kind of either have to assume it away, for example, if you're dealing with someone that you've known for 50 years, or you have to find a way to manage it. So in a nutshell, the current process is quite paper heavy. The reality is that documents are being couriered all around the globe every day to be checked by banks and to be sent to buyers and so on and so forth. It's quite manual because you have humans actually checking that everything is in order. And it takes a long time to process, depending on the countries. Not everyone operates as efficiently as the Germans, to put it simply. So where does blockchain come in? On the one hand, you have blockchain, which is a technology of trust. It's a source of decentralized and distributed truth that you consider credible. On the other hand, you have international trade, where frictions in trust lead to a lot of paperwork and a lot of proliferating intermediaries. So when you consider this, you can see that blockchain is a theoretical use case for international trade to kind of bring it into the digital realm. And how does this look like in practice? So the bill of lading that I just described, this could become digital, right? Because the blockchain could validate who actually has title to something being shipped in a reliable and secure way. Similarly, on other documents, you can have the third parties issue them on the blockchain, and that kind of validates them as reliable, credible, and secure. So in a nutshell, it's kind of an opportunity to establish a quicker and more algorithmic approach to payment, but also general workflow. But beyond that, so beyond this idea that you can have efficiency gains with automation and digitization and so on, with no sacrifice in security, you actually start laying the groundwork for an integrated digital system of global trade, because you may be able to solve this kind of trust friction. But also, speaking high level, it also sets out the vision of a more democratized supply chain, because smaller players can now interact without having to rely on either larger players or intermediaries. And also it promotes visibility. So you can imagine a world where you take your iPhone, you scan the QR code, and you can kind of securely and reliably trace back your food or to where it came from, or trace back a certain mineral to say, okay, this was produced ethically in a digital and secure way. So the last thing before we move on is to ask why blockchain. Because in theory, you can have Amazon do this, right? You can have you can have a bank. You can have someone decide to set up some sort of database or server to manage trade. But the point is that blockchain is a neutral platform, so you don't have to rely on banks. You don't have to rely on like a buyer or a seller. Yeah, of course, like Switzerland, and you always trust the neutral Swiss with your money, right? So now my clicker is not friendly today. So now I'm going to take you through my first attempt to build a decentralized application to kind of model how this would work, to build a minimum viable product that models a basic trade transaction, and take you through the technology stack that I used. So when I started, I had a lot of buzzwords thrown at me, and they didn't really make sense at first. I had to kind of take them and try to understand like how does everything relate to each other. So let's start with the basics, and this may be a refresh for some of you. But first, Ethereum. What is Ethereum? You can think of Ethereum as a blockchain with a built-in programming language. So you have applications that are built to serve a specific purpose for their users, but are executed in a decentralized way that doesn't rely on a particular server or database existing. A more technical way to describe Ethereum is a consensus-based, globally executed virtual machine. So a virtual machine is something that provides the functionality of a physical computer without being physical, and in this case it's globally executed because its nodes are really all around the world, and it's consensus-based because any changes to the state have to be approved by the majority of Ethereum nodes. And Ethereum has this thing called the Ethereum virtual machine, which is the part of Ethereum that performs computing. So it kind of provides the runtime environment for smart contracts to run on the Ethereum blockchain. Next, we have Solidity. So Solidity is the language that you use to write smart contracts on the Ethereum blockchain. It's object-oriented, it's statically typed, and just like other languages that you may be familiar with, it needs to be compiled to something that is executable on the Ethereum virtual machine. So you have this thing called the Solidity compiler, or SOLC for short, that basically compiles Solidity code into bytecode that is readable and executable on the Ethereum virtual machine. Next, you have Web3, and this is essentially the official Ethereum JavaScript API. So from a JavaScript application, you can read and modify the state of the Ethereum blockchain, or specifically interact with contracts that are on the blockchain. Finally, you have the Truffle suite, and unfortunately it's not a dessert menu, but it's actually called Truffle, Drizzle, and Ganache, and it serves as a kind of Ethereum Swiss Army knife, if you will. So to start, it was incubated by this company called Consensus. Consensus is a famous company in the blockchain space that's been quite active in growing the Ethereum ecosystem. So a lot of Ethereum-based startups have been incubated by Consensus. Unfortunately, the suite itself doesn't include any chocolate, but it does provide syntactic sugar if you are an Ethereum developer. So, starting with Truffle. What does Truffle do? A few important things. you can manage your networks. So are you connected to a test blockchain? Are you connected to the real Ethereum blockchain? Are you connected to other to a blockchain on your own machine? That's all easily manageable on Truffle. It also includes the Solidity compiler, so that also becomes kind of seamless and easy. And it also provides a test framework so that you can test your contracts as you're writing them. Next, we have Drizzle and Ganache. Ganache is essentially a test blockchain that you can initialize on your own machine, and you can. I'll show you what it looks like afterwards. But you can configure its parameters, and you can interact with it as you would with a real blockchain. And Drizzle is like the front end link, so it connects to the Ethereum blockchain via Web3. The way I've experienced it, it's kind of like Web3 plus a few features that make it easier to interact with. So we started with this cloud that, frankly, when I started was confusing to me, and then I came up with something that was maybe even more confusing. But to explain it to you, this is how everything. To recap, this is how everything relates to each other. So we start with our Ethereum blockchain that has the Ethereum virtual machine. And then we have Solidity, which is a language you use to compile smart contracts, to write smart contracts. And this language is then compiled into the Ethereum virtual machine via this thing called Solk. And yeah, we can either be talking about the real Ethereum blockchain or a test blockchain like Ganache. Now moving to the front end, you have Web3.js that will communicate with either of your blockchains to interface with your JavaScript application. And Drizzle here will add some functionality to Web3.js. And the final thing that we didn't discuss is MetaMask. And MetaMask is a browser extension that connects to the Ethereum blockchain. And it allows you to basically interact with the Ethereum blockchain. So have an account, manage your wallet, but also sign transactions if you're interacting with a smart contract. So moving on, what would an international trade transaction look like if it were executed on the blockchain? So the way I visualized a minimum viable product was basically as follows. You start with the buyer deploying a smart contract to the blockchain. So this says, okay, this is the buyer, this is the seller, this is the product, this is the quantity, these are the contract details. It's now a smart contract on the blockchain. Next, the buyer funds the contracts. So the way this works is that if a few criteria are met, then the smart contract should somehow trigger a payment to the seller. So for it to be valid, it needs to have actual funds in it. So if you have a smart contract that isn't funded, it can't really be executed in a meaningful way. So you either need it to be funded, or you need some sort of algorithmic approach to the payments from the buyer to the seller that would execute in a smart contract. Next step would be for the carrier to issue a carriage confirmation, right? So to say, okay, the 10 containers of coffee are now on their way. And this is the third party validating to the buyer that what he bought is underway. Now in the real world, it would be more than the carrier. And okay, once that's done, if the smart contract validates the documentation, then the seller can trigger a payment to his own account. But yeah, as I said, in reality, you'd have more nodes in an ideal world. So the carrier, but also the different bodies that are issuing documents that are relevant to your transactions. So, people who are weighing the cargo, people who are inspecting its quality, customs, and so on and so forth. So, demo time. Right. So first, let's start with Ganache. This is the blockchain that's running on my machine, and you can see like I have 10 mock accounts with 100 ether in them. You can see the blocks as they're being mined and what's in them. You can see the transactions and all the logs as well, and you can kind of configure the parameters of Ganache. So this is the interface that I was able to build. What I've done so far is already deployed a few contracts. If you noticed on Ganache, one of the addresses actually had less than 100 ether, and that's because some gas was spent to actually deploy the contracts. And the problem I've encountered just running this on my local host is that kind of MetaMask needs to be reset often. So if that does happen, just bear with me. But that's kind of one of the fallbacks of working with a local host. So what I'm going to do now is try to create a new contract, which means deploy it on the blockchain. So what's going to happen here is it's going to ask me to confirm the transaction. Once I confirm it, I should have a new contract pop up. And once I click it, I get the details of that contract. So we've just the basic kind of skeleton would be to specify a buyer, which in this case is a contract address, a seller, also a contract address, a carrier, which is going to validate that the goods have been shipped, and just the quantity and price parameters. Now, what we're going to do now is fund the contract, and of course only the buyer can do this. And what MetaMask allows you to do is kind of toggle between accounts. So if I try to run the command with using the seller account, it would actually reject it. So we can try. Yeah, so it's showing me a transaction error, and if I try to confirm it, it'll reject it as well. So I'm gonna reject this one. But on the other hand, if I switch my contract to the buyer, it should go ahead. And here, why is it sending 7 ether? Simply because what we've done is specify quantity of 7 at price of 1. So this can be metric tons or containers. This is still very abstract. But if I confirm it and then I click again to call the new state on the blockchain, you can see that the contract balance has now become 7 and the status is funded. Now that it's funded, we can wait for the carrier to confirm that the goods have been dispatched. And of course, the point is that only the carrier can do this, because they're the third party that are going to validate in a digital and secure way that the buyer or that something is on the way to the buyer. So again, I have to switch the address that I'm using to carrier, and that corresponds to what was specified when we created the contract. So when I click dispatch, it should give me the same screen, and confirm it. And then once I click here, it should show me that the status is now in transit. Now that the status is in transit, the seller has theoretically fulfilled his or her obligations, so the funds can now be redeemed. So if I change my contract, my address to the seller, and click on redeem, it should give me the same screen, confirm, and once I refresh the state, balance goes to 0, status is completed, and you can see that the seller now has 7 ethers more in his account minus whatever gas it cost to run the transfer. So this is kind of a minimum viable product that I was able to build. Of course, a transaction would look far more complex than this, but it is my hope to kind of keep dabbling with it and bringing it to something that looks more realistic. But as I said, it is a complex kind of ecosystem that we're dealing with. Now some insights. As I said, I'd like to continue working on this, develop various UI and smart contract functionalities. And I do think that the Truffle suite is kind of a good way to get started for Ethereum development. It takes some time to learn, but it's quite straightforward if someone is interested in getting started. What I did have some trouble with is Drizzle versus Web3.js. So Drizzle is the front-end framework for the Truffle suite, and it's fairly young. It was released not so long ago, and it's still kind of unclear to me how to use it well. So I found myself using the Web3 instance inside Drizzle very often, and actually finding some bugs that Drizzle has but Web3 doesn't. So that's kind of something I'm going to keep watching and trying to delve more into. The other thing that was kind of troublesome is that MetaMask has its own kind of UI logic. So if you're trying to build an app with Vue or React or technology like that, it's kind of hard to get the MetaMask UI to kind of not clash with the UI that you're trying to build. So that's something I'm going to be looking into. Of course, identity management would be kind of a cornerstone to this kind of system because it depends on the third party that validates whatever needs validation being the actual third party. So you need a secure way of validating identity on the blockchain. A bunch of companies have tested pilots there, and one of them is Uport. And inside the Truffle documentation, you'll actually find an integration with Uport that you can experiment with, and that's something that I'm gonna be working on. Now back to the high level. Where is this going? From experience, from having been on the inside, and from staying up to date on the topic, the industry players see the disruptive potential there. Trading companies are typically running pilots on the for blockchain transactions, and banks that act as intermediaries are also seeing that actually this might disrupt us, so we need to get ahead of the curve. But we're still largely in the proof of concept stage. As far as I know, there's no production scale solution that's been implemented. Overall, it's these big companies that are working on it are biased towards what I would call a consortium approach, which means that you band together with other large companies, you create a blockchain, and you kind of play with it together. This is probably a good thing to get started, but my question mark is whether this fits with the general vision of the blockchain being an open and neutral system. So to think of a recent example, Some of the world's major oil companies banded together to create an oil blockchain to transact between themselves. It's probably good for the development of the technology, but I think it wasn't the idea of Satoshi Nakamoto and people setting out on this journey that you still have something that's controlled by BP and Exxon. It has to be neutral and open. So if I can summarize the challenge, it's basically you have a large number of ecosystem nodes. In one transaction, you're going to have a buyer, you're going to have a seller, you're going to have a bank, you're going to have a shipping line, you're going to have 5 or 6 different bodies that issue documentation that is required. So to actually build something requires getting a lot of people to move together, and that presents quite a coordination problem. If you multiply that, 10 nodes on one transaction, and you think about the number of transactions that happen around the world every day, and the number of countries that you're dealing with, it's quite tough to get projects moving forward. So a solution would have to be a nice, flexible, plug-and-play solution. But how do you get there? It's not easy because the ecosystem is so complex. There are so many different forms of transactions. There's quite a diversity in what a transaction could look like. So it's tough to build a platform that accommodates everybody. So what I'm personally watching, but I'd be interested to hear your thoughts, is this thing called blockchain interoperability. So blockchain interoperability is this idea that blockchains can talk to one another. So you build a blockchain that is suited to a particular purpose, let's say a banking blockchain, and this blockchain could talk to another blockchain that is suited to another purpose, let's say a shipping blockchain. Now, we're not there yet. There are a lot of projects trying to get this off the ground, in the same way that eventually today you have HTTP as a way for a different machine, as a way to communicate over the internet. You need this basic standard for blockchains to communicate between one another. But yeah, my view is that once this is, or if this is solved, it will be past really one of the big hurdles towards making this a reality. And yeah, that's kind of what I'm keeping an eye on. So thank you for coming today. Any questions, I'd be happy to discuss. And yeah, here are my details if you would like to keep in touch.
What is Merkle tree and how it helps to blockchain?
What is what? Sorry?
Merkle tree.
Merkle tree?
Yeah.
What is that? Sorry. Merkle.
It's something like hash table. It's used to build a blockchain.
I'm not familiar, unfortunately. But you're talking about
Implementation of blockchain.
So yeah, I'm guessing this is a lower level blockchain. Yeah, I'm not I guess I haven't built my own blockchain yet. I haven't heard of Merkle tree. If you're asking about proof of work, do you know what proof of work is? Or, yeah, I haven't. So I haven't. I can explain to you proof of work, but Merkle tree I haven't heard of, unfortunately.
Yeah. Merkle tree is the file's hash. It's a tree.
Yeah, it's a hash tree.
Oh, okay. No, I haven't heard of it. Yeah, I haven't delved into the lower levels just yet.
Have there been any social contract in production, implemented?
Yeah, so you've had various pilot projects that actually were successfully executed, but none of them have been brought into production.
What do you think are the problems with that?
What the challenges are?
Yeah, the challenge.
The challenge. So as I was explaining, it's difficult to build something that suits everybody, and there are a lot of ecosystem nodes that would need to be happy participating in this platform, and that's kind of difficult because the complexity of the ecosystem. Yeah, there's just a lot of nodes, and there are hundreds of different ways that a transaction could look like. And you know, trading buying washing machines from another country is an entirely different animal to buying coffee from another country. So it's quite hard to design kind of a one-size-fits-all. And that's why I was talking about this idea of interoperability.
What is a lot of project is working on to solve that interoperability? What is that kind of, what is the roadblock to achieve that?
It's technological. It's kind of, you know, you have developers working on on solving the problem. They haven't gotten there yet, but one of the main projects is called Polkadot, and it's being led by a guy called Gavin Wood, which is one of the guys who was the early actors in Ethereum.
Do you know where are they right now?
Polkadot?
Yeah, Polkadot. I mean,
technologically speaking.
Technology-wise, I know they are working on compatibility or what they call interoperability, and he is a very famous guy. And, do you know where they are right now?
I feel that they're supposed to deliver sometime in 2019, but they haven't delivered yet. So yeah, that's I think stepping back to the high level, there were a lot of projects that came out in 2017 with a 2-year timeline, and this year 2019 is where we see which were the serious ones and which were not.
All right, thank you. One quick thing is, if you are interested in blockchain, we just finished developing a blockchain masterclass. It's 2 weeks long, part-time, Mondays, Wednesdays, and Saturdays. I'm actually going through it right